Page 115, lesson 5, we're looking at graphing proportional relationships. So we have a graph that shows the time it takes JC to print t-shirts for her school's math club. And they want us to use the points on the graph to complete the table and then tell whether the quantities are proportional. So if we look at the graph here, by looking at the graph we can see that one t-shirt takes 5 minutes, 2 t-shirts takes 10 minutes, 3 is 15 minutes, and 4 would be 20 minutes. Okay, so just filling in based off of what's on the graph there. And then the next question is whether these are proportional. So if you remember, we talked about earlier in the chapter constant of proportionality. So if we do y divided by x is our constant of proportionality. So in this case, minutes is our y, shirts is our x. So if we do y divided by x, that's going to tell us how many minutes it takes per shirt. That's like our unit rate. So 5 divided by 1 would be 5. 10 divided by 2 would be 5. And you can do it for the other two. 15 divided by 3 is 5. 20 divided by 4 is 5. So all of those are coming out the same. And so the question about whether these are proportional, on part A, the answer would be yes. And again, for explaining that, we would say, you know, the ratios are equivalent. All the ratios equal 5/1, or it's 5 minutes per t-shirt for any amount of t-shirts that you make. Okay? So before we look at example 1, the book will talk more about this with you guys later, but I want to go ahead and mention it up front with you here. Proportional relationship, the graph goes through the point 0, 0, and it's a straight line. Point 0, 0 we've talked about before. It's called the origin, okay, is another name for that point. So if we have starting at 0, 0, and we have a straight line, that's a proportional relationship. So in other words, if they give me a graph rather than giving me points, just by looking at that, with that information now, you know, looking at that problem we just did, by drawing a line, I could see that would be a straight line through 0, 0. Without even working it out, I would know that that's a proportional relationship. So on example 1, Tanya exercised for 30 minutes. She noted the calories burned at 3 times during her workout. How can Tanya use this information to find how many calories she burned after 15 minutes of exercise? So they're giving us some information. So we see after 10 minutes, after 20 minutes, after 30. So 15 minutes would be between the 10 and the 20. One of the things we would want to do here probably would be to make sure that the calories she's burning is proportional. So that's kind of what they're doing in the book here. They graphed some points. So they graphed after 10 minutes, 95 calories. After 20 minutes, 190 calories. After 30 minutes, 285 calories. And then basically they drew a line through those points. When they drew a line through the points, they made some observations here. Observations would be, it's a straight line. It goes through 0, 0. Those observations, like we just talked about, tells me that this is a proportional relationship. Okay? Straight line through the point 0, 0. We could use the graph to find the constant of proportionality. I'm not a big fan of how the book's doing this. With this part here. But basically, I'm just going to switch it around, and you might think I'm being really picky, but you might see later why we're doing it this way. basically from any point on the graph to get to another point, I can go up 95 and over 10. Okay? And graphically, you guys might look at that, you might say, well, it looks like we're going over more than we're going up. Well, that has to do with the scale they chose. The y-axis, they're going by 50s, and the x-axis, they're really, if you look in between, they're actually going by 2.5. So that's why it looks like we're not going up as far as over, even though we're going 9.5 times more up than over. Okay? So that's the deal for each of those. Now, we've talked about before y over x is like our constant of proportionality. Something kind of a preview, don't worry about it at this point too much, but a preview for later is even if it's not proportional, we can actually look from one point to the next if we have a straight line. This little triangle, it means a change. So change in y over change in x. Okay? So for any line, we can actually look from one point to the next. If it's a straight line, how much did our y change by? How much did our x change by? If you divide that out, that is going to be for any line what we'll learn about later as what's called slope. Okay, that's a preview of something to come here. But going back to this then, well, let me finish this thought, I guess. So with these, since it is proportional, you could actually take any y value divided by any x value. So if you like smaller numbers, you could take the 95 divided by 10. Divide by 10 is just going to move your decimal one spot to the left. So that would be 9.5 calories per minute that they burned. 9.5 calories per minute. And so that would be our constant of proportionality. Now the book's not quite doing all the steps here like we might normally do. If that's our constant of proportionality, that's our k value, right? So we talked about the equation y equals kx. So an equation for this line would be y equals 9.5x. So that's helpful because rather than, we could look at the line and say, well, at 15 minutes, it looks like they burned this many calories. The problem is it's hard to tell sometimes, plus if our line's not perfectly straight, that's a little bit of a difficult thing for us to do. So a more accurate method would be to use our equation and say, oh, 15 minutes, I'll substitute 15 in place of my x. Okay, because x is our number of minutes here. And then if you multiply that out, and you should get what they have in the book, 142.5 or 142.5 calories that they burned in 15 minutes. Without doing all the work that they did on this problem, just to show you another option is we could actually just check out if this is proportional by dividing. 95 divided by 10, that would tell us calories per minute that we burned. So that's 9.5. If you did 190 divided by 20, you'd get 9.5. If you do 285 divided by 30, you get 9.5. So that would technically be an easier route of doing this problem than what the book's doing, but what they're doing is valuable information for us for some other things that we'll do later on. And so by finding that constant of proportionality is 9.5 calories per minute, you could actually then just take 9.5 times 15 and you'd be done with the problem. Okay, so less work than what they're doing here, but again, there's some valuable information that we can get out of what they did. So So the try it, each 1/4 cup serving of cereal has 3 grams of protein. How can you use the graph at the right to determine whether the quantities are proportional and to find out how many grams of protein are in 1 cup of cereal? So the graph, if you look at the graph, it's just a blank graph there. So they've got some things filled in. They've got an X and a Y telling which one's which and stuff like that. So that's helpful, but we don't have anything actually graphed out yet. So we could look at graphing this out. Again, this is technically more work than what we'd have to do to figure this out, but that's okay. 1/4 cup of cereal is 3 grams of protein. The next spot they've got basically marked here on the x-axis is a half, and we know a half is the same as 2/4. So that's another 1/4 of a cup. So another 1/4 of a cup, another 3 grams of protein. So that would put us up to 6 grams of protein. 3/4 a cup would be 9 grams of protein. And then the 1 cup, we would actually be off the charts there. So if you graph this, ideally, you guys could use the edge of a piece of paper or a ruler if you had a ruler, if you want to try to make an accurate straight line here. When you make your line, you want to go past your last point a little bit, put an arrow on the end to show that that keeps going. So once we graph that, we could look at our graph and talk about what we did earlier to see if it's proportional. So proportional, it should be going through 0, 0, and it should be a straight line. So since this graph has both of those qualities, this would be a proportional relationship. So yes, it's proportional. And then we want to find out how many grams of protein in 1 cup of cereal. Well, technically we could extend the pattern one more step, right? 3/4 a cup had 9 grams, so 1 cup would be 12 grams of protein. Another option, again, we wouldn't have to go through all this process of what the book did in order to figure this out. We could look at how many grams of protein per cup. So if we have 3 grams for 1/4 a cup, like we've talked about before, you know, technically you could say, well, I'm going to divide both of these by 1/4, or like I've mentioned before, if you just take the number of grams divided by the number of cups, that will always give you a unit rate. So if we do 3 divided by 1/4 is like 3 times 4, keep change reciprocal. That's 12 over 1, which is the same as 12 grams of protein. So, you know, they told us it's 1/4 a cup for every 3 grams. Every 4th cup is 3 grams of protein. So just by their statement, we should probably know that that's going to be proportional. And then technically just working that out, we could figure out how many grams of protein for 1 cup. And again, some of you guys may have different ways of, you know, drawing pictures or other methods that might you might find helpful to figure that answer out of 12 grams. And going back over to our graph again, if you took any point on this graph, if you did the y divided by x, you'd get 12. In other words, 6 divided by half, you get 12. 9 divided by 3/4, you get 12 as well. All right, and they didn't ask for it here, but they could have asked what the equation is. Since our constant of proportionality was 12, then the equation for this line actually is y equals 12x. Example 2, the graph shows a proportional relationship between the distance and the amount of time Mr. Brown drives. What does each of these points represent in this situation? 0, 0, 155, and 5, 275. If we just look at the graph, look at the labels on the x-axis and the y-axis. That's going to basically tell us the answer to this problem. X is our time and y is our distance. So if we look at the point 0, 0, that's 0 hours, we've gone 0 miles. Makes sense? We can't go anywhere if we don't have any time to drive anywhere yet. 1:55, again, the 1 is our hours, so that's 1 hour. We went 55 miles. The book's kind of got it backwards from how I would probably put it, but that's okay. And then 5:275 says in 5 hours he went 275 miles. Okay? Now, they did tell us it's proportional. Even if they didn't, we know it's proportional because it's a straight line through the point 0, 0. The next question is, what is the constant of proportionality? Constant of proportionality, what we're going to try to do is look for where x is 1. Where x is 1, that's going to be my unit rate, that's going to be my constant of proportionality. Because that tells me after 1 hour, he went 55 miles. That tells me he went 55 miles in 1 hour, or he went 55 miles per hour. Okay, so if I can find that point on the graph, that's a valuable point for me to look at to figure this out. So that tells me 55 then is my constant of proportionality. And if I know 55 is my constant of proportionality, our equation, since it's proportional, our equation is like y equals kx. And so my equation then would be y equals 55x. So if we look at the try it, suppose the graph of Mr. Brown's road trip is extended. Find the ordered pair with an x coordinate of 7. What does this point represent in this situation? Well, we could physically try to extend this line here. And especially if we had a ruler and we drew a really straight line. Kind of the problem is I get to 6. I get to 7, and then it's like, well, was that the same distance apart? And then they're going by 50s over here. No, they're going by 55s on the graph. And so this is going to be a little bit difficult for us to detect. You know, you might look at it and you might say, well, yeah, but they're going up 1 and over 1 by how they've got it, which is really up 55 and over 1, right? So we could continue that pattern, up 55 over 1, up 55 over 1. Another option you guys have besides doing that, we just found an equation, y equals 55x. We could actually use that equation and figure this out pretty easily. So on the graph, x was our time. So if our time is 7, or they're telling us the point is 7 something, so x value is 7, you could just substitute 7 in place of x, multiply that out, and you get 385. So that means the graph would pass through the point 7, 385. So this tells us that Mr. Brown drives 385 miles in 7 hours. Again, the y is our number of miles, and the x is how many hours that he drove for. Example 3, explain why each graph does or does not show a proportional relationship. So basically 2 things we're looking for. Does it go through 0, 0, and is it a straight line? So example 3, if you look at the first line, it does go through 0, 0. It is a straight line, and so that is proportional. The second line is a straight line, but it doesn't go through 0, 0. It goes through 0, 30. That does not work. So that is not proportional, okay? And then the last line, it goes through 0, 0, but it's not a straight line. So that's not proportional. Okay, again, it has to do both of the things, straight line and through 0, 0, for it to be proportional. All right, so on the try it says draw two graphs that pass through the point 2, 3, one that represents a proportional relationship and one that does not. Label your graphs as proportional or not proportional. Okay, so we know both of the graphs are going through the point 2, 3. So we could plot the point 2, 3 on both of these. One's going to be proportional, one's going to be not proportional. And so again, like we talked about, proportional, it's got to be a straight line, it's got to be going through the point 0, 0. So something like this for the proportional line. Not proportional, again, you could have it not starting at 0, 0. You could have it not be a straight line. You could have both of those things happening, I guess, to ensure that it's not going to be a proportional. So the key concept, again, like we've talked about, if we have a proportional relationship, it's a straight line through the origin, or in other words, through the point 0, 0. If it's proportional, y divided by x, our constant of proportionality, is going to be the same for any point that we pick, except for 0, 0. We can't take 0 divided by 0. We can't divide by 0. That's undefined. Okay? And again, for future considerations of what we're going to do, I'm not a big fan of how they're showing that part in your book. I would say we go up 5 and over 1. Shows $5 per ticket. Okay, I know what they're doing is kind of like that too, but the y over the x is kind of what we want. So that's why I'm looking at the y first and then the x. Okay, and again, that has a little bit to do with the slope that we'll talk about later on. Let's look at do you understand number 3. Michaela plotted 2 points 0, 0 and 333 on a coordinate grid. Noah says she is graphing a proportional relationship. Is Noah correct, and explain? Alright, so if we think about this, we've got 0, 0, and then somewhere we've got the point 333, however that is. Okay, so a lot of times looking at this, people will look at it and say, it goes through 0, 0, and it's a straight line. So it's proportional. And we're kind of making some assumptions. Our brain maybe even is just making some assumptions here. The graph might look like that, actually. Okay, without any other information, we actually don't know if this is actually a straight line or not. We don't know what the situation is, and so for that reason, we could just say we don't have enough information to determine whether it's proportional or not. Okay, so just that statement would be fine. We don't have enough information to determine whether it's a straight line. Okay, we do know it goes through 0, 0. The straight line is the question mark here. So if we look at the do you know how, Martin and Isabel go bowling. Each game costs $10, and they split that cost. Martin has his own bowling shoes. Isabel pays $3 to rent shoes. So they want us to complete the graphs here. One thing we might want to think about first of all is If each game costs $10 and they're splitting that part of the cost, so $10, they're splitting it between the two of them, would mean each of them would be paying $5. Good. Okay. All right, so it's $5 per game for the bowling part of it. But again, the shoes is going to be the difference maker here between these two situations. So since Martin has his own bowling shoes, he's just paying the $5 for the game. So one game costs him $5. 2 games would be $10. We could continue. 3 games is $15, and so on. What's going to happen here is that if we drew a line through these points, it would be a straight line. It goes through the point 0, 0. Okay, now obviously some of these points on the line that are in between the points we drew don't really make sense because they're probably not going to let you play 1.5 games or something. But anyway, this is enough for us to see Martin's straight line through 0, 0 is proportional, which actually goes along with question number 5. So question 5, which graph shows proportional relationship? So that would be our answer for number 5. And then we can go back and look at Isabel's graph. So Isabel's graph, slightly different situation because she is paying to rent shoes. So she's going to pay the $5 per game, but then she also has to pay for some shoes. So her first game, she is paying $5 for the game plus $3 for her shoes. So one game would be $8. They're going by 5s here, so that's going to be a little hard for us to draw. But that would be at the point 1.8. If you want to label it, since it's not an exact point, you can do that. If she plays a second game, she already paid for her shoes. Okay, don't pay for your shoes twice if you go bowling. The second game is just going to be another $5. So we had $8. We're going to add on another $5. And that would be $13 total. So 2 games, $13. And again, we could label that point if you want. You could do one more point if you wanted, would be another $5. So 13 plus 5 would be $18 for 3 games. Okay, if you want to do that, you can. And then what we're going to do is we're actually going to get a straight line through these points. The problem is that it doesn't go through the point 0, 0. So that starting point on this graph actually is the point 0, 3. And you might think, well, that doesn't make sense. 0 games and it costs $3. Well, that's the cost of the bowling shoes. So I guess, you know, don't recommend it, but you could rent bowling shoes for $3 and then just sit there and watch people bowl. Probably not much fun that way. But anyway, that's why that gives us that as a starting point, and that's why that would not be proportional for Isabel's graph. Number 6 asks us to choose one point on the graph of the proportional relationship and explain what it means in terms of the situation. So if we go back and look at Martin's graph, so we could pick any point on that graph. One option we could pick the point 210, which means that 2 games cost $10. So on this question number 7, the equation of the proportional relationship, we talked about it earlier. Basically, Martin is paying $5 per game. So $5 per game, that's our unit rate. That's our y divided by x for any point on the line. So kind of like we looked at before, y equals kx, but our k value here is 5. So y equals 5x would be the equation for that line.